So here's sort of a procedural explanation of the experiment that you're going to be doing as your lab practical. Remember, we're not going to be discussing this in lab at all. You're going to come in, you're just going to do the experiment, and you're going to walk out. Our goal in this experiment is to determine the amount of citric acid and sodium bicarbonate in an Alka-Seltzer tablet, probably an Alka-Seltzer tablet. The citric acid dissociates and forms hydrogen ion, right? So that's the business end of the citric acid. Sodium bicarbonate dissociates into sodium ion and bicarbonate ion, which is just a polyatomic ion, not on your list of ones to have to memorize. Bicarbonate acts as a base, hydrogen ion acts as an acid, so when they react together, we get an acid-base neutralization. There's our water liquid, but in this case, we are actually making carbon dioxide gas. And our goal is to figure out the amounts of each one of these things in that original tablet. So you're going to take a tablet, our Alka-Seltzer tablet, and we're going to drop it into water. And the limiting reagent in the actual tablet itself is the citric acid. So in this case, for our reaction, the hydrogen ion is the limiting reagent. If we measure the mass of the entire system, including the tablet and the water and the container, and we run the reaction, and then measure the mass of the system afterward, the difference between those will be the mass of the carbon dioxide lost, which I'm going to call CO2R1, so for the first reaction. Once we know the mass of the carbon dioxide loss, we can figure out how much hydrogen ion was in my original sample, because we can go from grams of carbon dioxide formed to moles of carbon dioxide to moles of hydrogen ion, moles of hydrogen to moles of citric acid, because that's what's actually in the tablet, to mass of citric acid. To figure out how much bicarbonate, what we want to do is we still have some bicarbonate ion in our original sample, right? So we've done this reaction. There's still some bicarbonate left. So what we want to do is we want to get the rest of that bicarbonate to react. So you're going to add an excess amount of acid. We're going to basically add some more acid to react the remaining bicarbonate ion. We're going to get a little bit more, so you're going to need to know how much HCl you added, because you're adding it to this container. We know how much we add our additional hydrochloric acid, reacts to the remaining bicarbonate, so we're going to lose a little bit more. We're going to have a little bit more carbon dioxide formed. We know then we can sort of determine the total amount of carbon dioxide that has been given off, because we know how much was given off in the first one, and we can determine how much was given off in the second one. That will give us all the carbon dioxide that comes off from all of the bicarbonate, basically making this the limiting reagent. So by knowing that total amount of carbon dioxide loss from the two different reactions, we can convert that mass of carbon dioxide total into moles of carbon dioxide total. Since now we've set the experiment to be bicarbonate to be limiting reagent, we can go from moles of carbon dioxide to moles of bicarbonate to moles of sodium bicarbonate to grams of sodium bicarbonate. Now, knowing the mass of the citric acid in the sample and the mass of the sodium bicarbonate in the original sample, we can calculate the mass percents, which is our goal for this experiment. Good luck.